Next speaker is Peter SCHULMEYER from Silicon Labs. He's the senior director there, and the title of his talk is Machine Learning in Wireless IoT Applications. Over to you, Peter.
Thank you, Steve. And hello, everyone. Thanks for joining this short presentation. My topic today is how to combine AI, machine learning, and wireless communication. First, let me, though, I just spend a few seconds to introduce Silicon Labs. Silicon Labs is a mixed signal RF company. The focus of my presentation will be the wireless part of this, wireless communication part, where we integrate processors and the wireless communication capability on a single chip. I'll be calling those just wireless SoCs going forward. Typical applications we're in this space are the IoT applications, right? Home, industrial, wide range of applications where we see a combination of wireless communication and local processing needed. So let's get to the main topic, which is how to combine wireless communication and AI on the same SoCs, right? So what we're talking about is how do you run both AI and machine learning, right, on your same single chip solution as your application and the wireless communication stack. The problem here that you'll be facing is there's a wide range of wireless communication technologies. Right? You can see on the bottom left here things we support, everything from Bluetooth, Zigbee, Wi-Fi, etc. So a wide range of wireless communication protocols that you might need to support, combined with a range of, let's say, for example, security requirements in your application. Of course, you still need to be able to handle the application. And on top of that, you want to run the machine learning inference on that same SoC. Our goal here is to make this as simple as possible for you. So we combine these various pieces for you already up front, and then essentially allow you to have a modular approach to these pieces so that you can develop your machine learning model independent of the details of what your application does and or what your wireless stack does, and then combine it on the same SoC, and it runs smoothly together. So our primary focus here is, again, to keep it simple and as straightforward for you as possible to do this integration of multiple pieces on the same processor. Where might you want to do this, right? So typically today, much of the AI applications run in the cloud. So that's not a space we're in. And even on the edge, right? We were talking on the edge, a lot of places you have a separate application processor or some other processor in addition to the wireless communication subsystem that can handle the machine learning inference part. So what we're talking about here is at the very edge of the edge here, called micro edge, essentially really close to the sensors and devices and actuators where you want to maybe possibly integrate both on the machine learning and the wireless communication on a single chip to achieve the space and power targets of this application. Why would you want to do this? Big one is lower power. We've run multiple simulations and calculations on this. Right? We've tried the kind of factor we see is maybe a factor of 5 to 10 lower power consumption of running machine learning inference on your edge device versus transmitting the data, for example, to the cloud. So this doesn't take into account the power consumption of the microcontroller in the cloud. This is purely locally at the edge. Right? It is more efficient to run the calculations locally versus transmitting the data. As I said, in our simulations and our calculations we did, we ended up with a factor of maybe 5 to 10 improvement in power consumption. Not always, dependent on the scenario, how often you need to communicate anywhere, etc. So it will depend on your specific use case. We've had examples where there was no power benefit, but in the majority of cases, there was quite a significant power benefit of, as I said, processing locally versus transmitting the data. Of course, you see bandwidth benefits, latency benefit of not having to go back to the cloud and return here, privacy and security, because if you're not transmitting the data, it's harder to get to it for any one trying to look at it, and there are cost benefits of not having to use the cloud infrastructure. So we are supporting TensorFlow Lite for microcontrollers across all our UFR32 products. That is our wireless SoC family, as well as the microcontroller family that goes with that too. We're talking wireless here, so it's the radio parts where we support TensorFlow Lite for microcontrollers across the board. Typical applications, right, is where we're talking at the edge. We are relatively small microcontrollers, right? So we are somewhat constrained in the performance and memory available. So the typical applications you'll see here use acceleration sensors or temperature, current, voltage sensors, or microphones. But then you're already starting to get to the limit of the data rate of the sensors we're talking about that we can address here with the single chip wireless SoC that we have. We support 2 development flows. I'll start with on the left. However, right, that's what I'm going to say later. I do recommend using the flow on the right, but it is available. So if you're familiar with and have the expertise in-house to create your own machine learning model using TensorFlow, we support the TensorFlow Lite for microcontroller development flow. So in essence, right, the training part happens and model development happens offline on the PC in your usual tools for that. Once you have your model trained, all the weights and parameters set, you can import that description of your model into your project. You then develop using our Silicon Labs tools, specifically Simplicity Studio and our development kit for the target application. As you develop your application, right, there's a simple click to include the TensorFlow Lite for microcontroller interpreter in your application. So that's just a checkbox you have to check in our Simplicity Studio, and it will automatically include the library to do that. And then you can just call the appropriate API calls for TensorFlow Lite for microcontrollers and run your inference on our processor. That works across a whole family, right? So you're not tied to a specific part. If you have a model that runs on one part, that model can be reused. Let's say if you'd like to use a different wireless protocol, or you'd find that you need a different set of peripherals, or you need more memory, etc., just pick another part from the family, and the same model will run with the same flow here. And so as I said, supported across the family. However, for most developers, I would expect that they will prefer the ease of use and ability of some of these partners we have. We have specifically 2 partners that we recommend, Edge Impulse and tinyML, both at the conference here, by the way. I'm sure you've seen some of their presentations. They have end-to-end AI development tools. Again, my recommendation is strongly to use these tools. The library they output, easily integratable into the wireless application, same as is on the left. Again, you're not tied to a specific processor from us. It will work across our whole family. And even for some unknown, strange reason, you actually want to use another company's product than ours, again, you're not tied to us at all. Both the flow on the left as well as these end-to-end tools from our partners work across the whole, not just our family, but many of our competitors' parts too. So in no way are we binding you here and tying you down to lock you in our products. We are highly confident in the competitiveness of our wireless SoCs, so no need to do that. Again, you have all the flexibility to move, and your models can be reused in either flow, whether you use the TensorFlow Lite directly on the left, or you use one of our partners' tools. But I mentioned, I would highly recommend use these end-to-end tools. We use them internally too. It is just so much more convenient to have those tools available for the whole development process. Here, as I mentioned before, right, one of the challenges here is there's so many different things that you need to combine on the same SoC, running on the same core. Not just your machine learning model, the inference part of it. You need to also run the application here. You need to run the wireless stack. We make this as easy as possible for you. Our solutions come with a stack for the radio, the drivers, etc., all already bundled nicely for you with example apps to make it as easy as possible to include your machine learning model in your application and the wireless communication in the same SoC. We have a large family of products. As a recommendation, if you're starting out, we have a board called Thunderboard Sense 2. It has a range of sensors that are exactly the right kind of sensors for the applications we're talking about here. Like inertial sensors, microphones, pressure sensors, etc., that have the data rate range that can be addressed with a machine learning model on an ARM Cortex. There's an M4 in this case, large amount of memory so that your model will hopefully fit. We have, as I said, a range of products. This is the one with a nice development board with the sensors on board. Again, supported by both edge imports and tinyML. But in no way are you tied to this board. The model that you develop on this board will work on all our other UFR products as well, assume you have enough memory. Right, so again, right, the emphasis we have is to make it as easy as possible for you to develop your solution, integrate it all on a single SoC. So we provide a set of tools that allow you to do that. There's a lot more to come, right? tinyML is at early stages, a lot more to come, right? Watch this space. We'll have more to announce in the future, but for now, across the board, no lock-in. You can run your models on any of our parts, import them between them. You can even port them if you need to a competitor part, if that's necessary.
Thank you, Peter. That was a good overview of Silicon Labs there and your wireless tools.
Again, just a quick shout out to our sponsors. Bear with me for 1 minute. We have different categories. We have executive sponsors. First one being ARM. Then we have Qualcomm. We have Samsung. Platinum sponsors. Ada Compute. Lattice Semiconductor. Gold sponsors. BrainChip. Babel Labs. DSP Group. Edge Impulse. EMSA. Gray Matter Labs. Greenwaves. Himax. Imagimob. Latent AI. Maxim Integrated. Quixo. Reality AI. SensiML. Silicon Labs. Sentient. Google TensorFlow. XMOS. And lastly, silver sponsors, Edge Cortex, Hotchi, and Synsense.